So in this video, we are going to discuss on AZ-204 exam, and believe me, this question 90% of the people are unable to answer this. And we'll also go through the system design interview questions. Okay, so please try to stay with me till the end of the video, and I will show you few system design interview questions as well. Okay, so now let's begin with the questions. So the question says, you are developing an application that applies a set of governance policies for internal and external services, as well as for applications. You develop a stateful ASP.NET Core 2.1 web application named Policy App and deploy it to an Azure App Service web app. The Policy App reacts to events from Azure Event Grid and performs policy actions based on those events. You have the following requirements. Authentication events must be used to monitor users when they sign in and sign out. All authentication events must be processed by Policy App. Sign-outs must be processed as fast as possible. So what should you do in this case? So option 1, create a new Azure Event Grid subscription for all authentication events. Use the subscription to process sign-out events. And option 2, create a separate Azure Event Grid handler for sign-in and sign-out events. Option 3, create separate Azure Event Grid topics and subscriptions for sign-in and sign-out events. And option 4, add a subject prefix to sign-out events. Create an Azure Event Grid subscription and configure to use the subject begins with filter. Okay, so the key requirements that you cannot ignore here is sign-outs must be processed as fast as possible. All authentication events must still be processed. Okay, so you need to prioritize plus filtering, not just separation. Okay, so priority plus filtering is must here, not just the separation. Okay, so now let's evaluate each option one by one. Okay, so let's eliminate the wrong options first. Okay, so the option 1 says single subscription for all events. So this is incorrect. Okay, why it is incorrect? See, like sign in plus sign out goes through same pipeline. Okay, so it is not prioritizing anything. So sign out may get delayed. Okay, so it is not acceptable. Option 2, separate handlers. So still tied to same event stream, so it doesn't guarantee faster delivery or prioritization, and it just different processing logic. Okay, so it also doesn't solve our latency requirement. So option 3 says separate topics plus subscription, so it is over engineered if you see. Okay, and authentication events usually come from same source, that is Azure AD or the system topic. So you don't control splitting into multiple topics easily. So it is not realistic or necessary. You are over engineering. Okay. So in this Azure exams, it asks how simple you can give the solution. Okay. Now see what is the correct answer and why it is. So we will use subject filtering with subject begins with. Okay. So in this case, Event Grid supports advanced filtering. So you can route sign-out events separately and ensure faster target processing, and still process all events just with optimized routing. So this directly satisfies all events processed and faster handling for sign-outs. Alright. So why it is important for AZ-204? So think it in event grid terms. So topic for source of events, subscription, routing plus filtering, filters, performance optimization. Okay, so instead of splitting infrastructure, you filter intelligently at subscription level itself. Okay, so that is why it is important. Fine. So now let's move to the next question. If you see here, it's question 6 and the previous question was question 5. All the previous question from 1 to 4 you will find in my previous 4 videos on this AZ-204 exam, where I have shown the questions along with answer and explain in the similar manner. Okay, so let's begin with the question. So you are developing a stateful order processing application named Order Processor. The application is built as an ASP.NET Core web app and deployed to Azure App Service. It receives high volume orders from multiple point of sale systems. You decide to use Azure Service Bus to decouple order ingestion or order processing for better scalability and reliability. So you have the following requirements. All orders must be processed in the exact sequence they were received from each customer. If a message fails to process after the maximum number of delivery attempts, it must be moved to a dead letter queue for later inspection and reprocessing. So I have discussed about dead letter queue in my previous video. I will add this video, my previous video, at the end of this one. Okay, so you can get to know about the dead letter queue in the service bus. Okay, so it also says the solution must support multiple concurrent processors while guaranteeing order processing per customer. What should you do? Okay, so with this requirement, what should you do? So it has provided 4 options. So option 1 says use a standard service bus queue with duplicate detection enabled. Set the log duration to 5 minutes. Enable session on service bus queue. Set the session ID to customer ID. When sending messages, use a session aware receiver in the order processor. Create a service bus topic, that is number 3. Create a service bus topic with multiple subscription. Apply a SQL filter based on customer ID for each subscription. And number 4, use a partitioned service bus queue and set the partition key to the customer ID. Okay. So let's analyze. So let us break down the requirement. So if you break it down, you see it requires strict ordering per customer, high throughput, so multiple processors, dead letter after maximum retries, stateful processing per customer. So the sequence matters here. Okay. So like previous one, let's eliminate the wrong options. Fine. So these are the 3 wrong options that you need to eliminate. So option 1 says standard queue plus duplicate detection. So duplicate detection not equals to ordering. Okay. Sorry. Messages can still arrive or process out of order. So it fails requirement 1. Okay. So option 3, topic plus subscription per customer. So it is not scalable. Okay. Imagine thousands of images, thousands of customers, thousands of millions of customers. In this case, it is not scalable. Okay, if you go with topic plus subscription per customer. Okay, so it could become a operational nightmare if you can't scale it. Okay, so it doesn't guarantee ordering as well per subscription. So it fails scalability plus ordering. Okay, so now come to option 4. It's saying partition key with partition key. So partitioning improves throughput, not ordering. So it is again not guaranteeing ordering. So no guarantee message process sequentially, as I told you. So this is very common mistake in exam. Okay. Now let's see the correct answer. So the correct answer says enable sessions on service bus. Set the session ID to the customer ID when sending messages. Use a session aware receiver in the order processor. So why this works? If you see here, service bus equals to ordered processing. Okay. And messages with same session ID equals to processed sequentially. Different session ID processed in parallel. So it meets all your requirements like ordering per customer, same session ID equals to FIFO, first in first out. Okay. High throughput, multiple sessions processed concurrently. Okay. So the requirement stateful processing So the session acts like a lock here. So it maintains your state. So dead lettering, that is the dead letter queue. So it is built in after max delivery attempts. So if the message fails after a particular amount of attempts, it will go to the dead letter queue. So as I told you, I have explained in my previous video, okay, about the dead letter queue in the service bus. Okay, you can go and check that. Even I will attach the link of that video to this one. Okay. So now let's move to the system design interview. Okay. So if you see with the high level design, okay, the question says, how do you design a scalable order processing system? So the answer should be, or you can answer in this way, okay. So I design an event driven architecture where API layer receives orders, pushes them to Azure Service Bus with sessions enabled. Each customer's order share the same session ID to ensure ordering. Scalable workers process these sessions concurrently, and downstream services are triggered via events. So this question you can answer in this way. Okay. So you have to mention the Azure Service Bus with sessions enabled. Okay, so the message can be processed sequentially. Okay, fine. So how can it can also ask an ordering guaranteed. So how do you ensure orders are processed in sequence per customer? That we had discussed earlier. You will answer, I use service bus session, setting session ID equals to customer ID. So in this case, Azure guarantees FIFO processing with a session while still allowing parallelism across different customers. Okay. So scalability, the question comes on scalability. So how does your system handle high traffic, suppose in Black Friday or any festival? Okay. In those cases, the traffic is huge. Okay. So in this case, you can answer, I scale horizontally by increasing the number of customers, okay, or whether it is Azure Functions or Worker Service. So each instance process different sessions, enabling parallelism without breaking ordering constraint. So the last question they can ask on the failure handling, how will you handle the failures? Okay. So if they ask, what happens is if processing fails? So again, the service bus retries automatically after maximum delivery attempts that it is configurable. Messages go to the dead letter queue. So we monitor dead letter queue and reprocess or investigate failed messages. So in this way you can answer. So that's all from the system design interview. So I hope this will help you, and if you find this video helpful for you, please like it and subscribe the channel as well. Okay, so it gives me power to create more videos for you. Okay, so thank you very much. Meet you in the next video. Okay, and try to solve these questions. Okay, bye.